My name is Ted Larsen, and I am going to talk to you about robots and 3D printing. I'm a robot nut, and if anybody, and there's some guys in here in the audience that know me. I'm a really active member in the Homebrew Robotics Club in San Jose, and I like anything that's robot related, and 3D printing is kind of like a robot that makes robots, so it seems like a natural fit. So who am I? I run a company in Sunnyvale, and I'm going to give you a shameless plug here, and then I'll move on to the real thing. We design the insides of other people's products. So it's an electronics design, it's hooking you up with a factory, it's making products makeable. We've designed products for people, big names like Hasbro and Google and Motorola and people like that. But we also have lots of startup companies that we're helping to make their products inexpensive, manufacturable, and help them get their product to market. I've been doing this now for almost 8 years. We're a small little company. We've made some pretty amazing products over the years. And that's that. So there's the shameless plug. Now we'll move on to robots. So I'm going to give a quick overview of 3D printing. I'm going to blast through this presentation because this is a presentation I already gave once before at the Robot Club, and I only have a half an hour, whereas last time I had more time. So, and you'll find out that a lot of people are going to talk about a lot of the same things, so I don't want to be totally redundant. But we're going to talk about, what is it, what are the various technologies that you can use, and the places and things where you can get things made or buy a printer that'll print. So here's all the different types. The different types are extrusion, which is like fused deposition modeling. This is where you force some kind of a filament through some kind of a heated head, and that filament is some kind of a plastic, and it slowly lays it down piece by piece by piece and builds it up into a real thing. Another one is wire. They'll take a wire and they'll, again, force it through a head. They'll use an electron beam to melt the wire in real time, and it'll slowly build it up layer by layer by layer by layer. Granular, or SLS, which means you take some kind of a powdered substance and they put it in a tray, and they use a laser beam to run around in the tray and fuse together some of the powder in the tray, and then slowly build it up layer by layer by layer. And when you're done, you end up with this 3D thing that you pull out of a bath of powder. And I'm going to pass around samples of things. So this was made using an SLS type printing material, and it's very granular. You can feel like when you're touching it, it's very gritty. And then there's also something called a powder bed inkjet. It's very similar to granular, except they use inkjet heads to color the powder as they're going, so you can print in full color. And then one of the most popular ones that everybody's loving these days is the technology that's been around forever. It's like the oldest 3D printing technology on the market, which is light fused polymer, or SLA. They take and they lay down a bath of liquid that's a UV curable liquid, and they slowly build it up layer by layer, and they either use a laser to fuse it, or they use some kind of a DLP projection head to project an image onto it. And some of the most expensive machines on the market these days are doing this high-end stuff. So let's look quickly at what the professional printers are like and what the various options you might have if you had lots of money to pay to buy one. The first one is the Objet Eden. This one roughly runs about $250,000. And it's a UV cure printing process, and its results are awesome. So here is a fully printed functional wrench that works. It's beautifully smooth and awesome, and this was printed on an Objet Eden. I'm going to pass that around. Super expensive. The post-process on the Eden is that you print it, it comes out, and you have to wash all of the extra support material off of it, and you use a high-powered water jet. And as a result, if you print a part with really fine details, when you're trying to wash it out, you can break it. So that's the number one complaint people have about this machine for the amount of money that you spend for it. Its number one competitor is the ProJet, and it's also a UV cured printing process. It can print in 6 different colors, and it uses wax to support the material. So let's say that I wanted to build a giant 3D model of myself in this position. If I was printing and I didn't have some kind of material that printed up under my arms while it was printing, I would slump. So that's the idea with a lot of these types of devices, is they have to print some kind of material to hold up the cantilevered or overhanging parts. And they use a wax support material. So the idea is you pull this thing out of the printer, and then you put it in this oven and you bake it, and then the wax magically melts off, and then you end up with a new model. And then here's another wrench that was printed on, this one's printed on a Stratasys, which is different. I lost my ProJet one, but I have samples pretty much of every machine print. Here's the Stratasys Dimension. This is an FDM machine, and they've been around forever as well. At least, I remember working with some of their machines almost 10 years ago. So again, same kind of an idea. It's fused deposition modeling. It builds it up in a layer by layer by layer by pushing something through it. I made a cool iPod case for my old iPod. You can see how dated it is. This was printed on a Stratasys, and it was printed on the lower end one, not the $250,000 one. I think that was the $60,000 printer. And then the Z printer, this is a powder bed inkjet. Let's see, the brown one of these, this brown one was printed on a Z printer. And it's very rough and kind of crumbly and weird. Again, the idea is it prints it in this powder bed, and you can see the guy down here. He's pulling up his part out of the bed of powder. And then the nasty part that they don't tell you about with these powder bed type printers is you infiltrate it with some kind of a substance to make it really stick together after it's printed. And the number one infiltrant is cyanoacrylic. We're talking super glue. So you take and you immerse the thing in a tub of super glue, which I don't know. They try to give it a pretty face to say, hey, that's not such a bad thing to do, but it's pretty gnarly. I mean, like, I've seen people that have it, and so then you say to yourself, well, gee, if I don't want to actually go out and spend $250,000 on a printer, I can rent time on somebody else's $250,000 printer. So there's all these companies out here like Quick Parts and Solid Concepts and Shapeways. You can send them your 3D part, they'll print it out, they'll charge you a fee, and they'll send it to you. And some of them you'll get it in a couple of days, some of them a couple of weeks. I've used all of these. Shapeways by far is my favorite because they're the cheapest, but they're located in Europe, so it takes usually a couple of weeks to get your parts once you send them in. So now let's talk about hobby 3D printers. And this is the truest statement ever. About 2 or 3 years ago, I was going to buy a hobby 3D printer, and my buddy says, don't do it, man. It's like a lifestyle decision. And sure enough, here I am giving a talk on 3D printing. I would have never thought that a while ago. And it's because you're constantly having to diddle it and tweak with it and mess with it in order to get it to produce the print results that you really want. So I'm going to talk first about the ones that are using UV cure that are well known out on the internet. Some of these have had massive Kickstarters where they've raised lots of money. And the two most popular right now are the Form 1 and the B9 Creator. The Form 1 is just really interesting. I'm going to see if I can launch this video. Let's see. Oh, it's not going to do it. Oh, well. Darn it. Anyway, they have this awesome video on this Kickstarter link, which I can't show you right now because it's not. You can try to make it go. But the way that this thing works, the way that this Form 1 prints, is it has a print bed that comes down and dips into a big bath of liquid. And they use a UV laser to move around and cure the layer that's in the bath. And slowly the plate moves up. And as it moves up out of the bath, this object magically appears out of the liquid, like it's coming out of a primordial ooze. And it's the most amazing thing because it's just, they have this time lapse of it printing, and it's like a bath of liquid turns into this really complicated looking object. And it's really almost creepy the way that it actually goes. We'll see if you can get him to get it going. So I'll talk more about, well, he's getting it going. The printer in the back that's printing right there, the little one, it's got a light on it. It's got a shape faced away from us. That's a MakerBot. And that's one of the more popular 3D printers that's out there. And that's a heavily modified MakerBot. And it produces really awesome print results. And I've got all these little cubes that we've made in various materials that I'll pass around. You can hold them and print them or touch them. Here's little other things. You've already seen all this. You designed all this stuff. Yeah. And what was your name again? Emmett. Emmett, right. And then I just found out like 5 minutes ago there's this really cool, there's a website where people publish their designs, and you can download them and print them. Oh. And you can download them and print them. And one of the more popular, interesting designs that are on there is this set of gears that you can print out, and you put it together and it makes a heart that you can kind of twist in the heart. It's like very artistic. And Emmett here, he's one of the more prolific posters on Thingiverse. And I just realized, I didn't realize I was sitting next to the guy that actually designed this little thing, but I'll pass this around. I didn't put mine together right. Yeah, you almost wish that I didn't pass it around because I did such a poor job of printing it and constructing it. So I'm apologizing in advance. So
25 years.
Here comes my favorite part of the whole video.
The way it works is pretty simple.
He's
using
a laser.
It's of a liquid plastic resin that hardens when exposed to a specific wavelength of light. After the layer is drawn,
here it comes.
The platform lifts, and the process is repeated layer by layer until the part is finished.
Ah, it's awesome. That's my favorite part of the whole video.
We have a great user experience.
But then the part that bothers me the most is she's got rubber gloves on, and then she's doing some kind of gnarly post-process with it, which, yeah, she's doing some kind of gnarly post-process to it, which I don't really fully understand, and I don't know. You can tell it's some kind of nasty chemical because she's got protection on for sure. And let's see, how do I get this going again? So, again, most of these 3D printers that we're talking about, these FDM type machines, they all kind of came from this original printer, which was one of the first ones that most people made, which was called the RepRap. And it's kind of crazy looking. It's this one up here in the corner. And there's a lot of these different printers that have showed up on the market, and they're all not created equal. And some of them make it more of a lifestyle decision than others. The MakerBot is obviously one that's been pretty popular. It's not the end-all, be-all. It happens to be one of the ones that I own. That's what's printing in the back of the room. It prints in ABS or PLA out of the box, and you can go to layer heights of 0.1 millimeters, so you can end up with a really smooth surface. All the little boxes and pieces I've been passing around, these are all printed at 0.2 millimeters, so that gives you an idea of roughly like the capabilities of it. And they can print in dual colors. But it all was rooted from open source. And like this is where they kind of came from. They had two machines, the Cupcake and then eventually the Thingomatic, and then eventually the Replicator, which is the one that's back there. Again, some of the big issues are if you're going to print in ABS, you really need a heated build platform, because you end up with the plastic not sticking to the platform when you start to print, and then it peels off, or it falls off, or it screws up the print halfway off, or the little part of it lifts up a corner and it ends up with this weird lifted edge syndrome, which this one right here, it lifted while it was printing, so you can get an idea of how it screws up your thing here. Okay, I'm just checking my time. Okay, so MakerBot started out as a total open source thing. They wanted to be all open sourcey and cool and hip. And then somebody came along and made this thing called the TandyBot, which essentially was somebody downloaded the entire open source design and then tried to run a Kickstarter to like make a whole new robot that was just the direct copy of the Replicator 1. And this freaked out MakerBot, and then they decided that they would go closed source on the later releases of the MakerBot. So the MakerBot 2, the Replicator 2, and the Replicator 2X are based on a closed source design, which is too bad. And then here's some of the knockoffs. So here's one that's not like a direct knockoff, but it's a Chinese-made one. It's called the MBot 3D. It's pretty cool. I've seen somebody that owns one. My favorite knockoff of all time is the FlashForge Creator. This one is not a direct copy of the Replicator 1. There's a lot of changes that have been made to it, okay? I mean, and there's subtle changes. It looks the same, but it's not really the same. So, and then here's my favorite one of all that you guys are gonna have a good laugh over is the Wanhao Duplicator. Now, this one is pretty much a direct knockoff, except it's in an acrylic enclosure, and it looks really cool and looks different, but it's not really different. Now, as far as like where I came from, I was doing this. If I wanted to make a part for a robot, I had to get out the CNC mill and cut it out. So I got this big honking CNC mill in the back of my shop. And to be honest, I got a 3D printer and I've used it only a couple of times since then, where I was using it all the time. So I went from that to this. Okay, now admittedly, there's the original Replicator 1 over here in the corner, and I bought the 2X, which the Replicator 1 cost about $1,500. The 2X costs $3,000. And I thought to myself, wow, I'm gonna get this better printer when I buy the $3,000 one. And it turns out that it's no better, it's the same. So save your money, buy the cheap one. And I like the MakerBot because it came from this open source roots, and you can basically make your own modifications to it and change it. You can download the plans to it from the internet. You can make your own new parts for it. And let's see. So to get something to print, you need to draw something in a 3D package. Like in this case, I'm drawing in SolidWorks, but it could be, there's lots and lots of packages out there like OpenSCAD and Rhino and various downloadable things that you can draw 3D parts in. And then once you've made your 3D drawing, you pull it into a rendering package that usually allows you to generate how the machine moves to print the thing out. And in this case, this is an open source package called Replicator G that basically will render it for many of the popular kind of RepRap offspring printers. So MakerBot, RepRap, a lot of these other printers, they all can be rendered in Replicator G. And then you basically have a file now that you can then take over to your printer, put in it, and print it. So now let's talk about modifications. So my MakerBot back there is no longer like the out-of-the-box one. It's been pretty heavily modified. And I found that I could modify my cheap one to print better than the $3,000 one by basically making these upgrades. So I upgraded the extruder, I enclosed the build area so that you don't get any breezes blowing across your plastic because it causes your plastic to crack and change. And the other big one is aluminum build arms. You want the arms on the printer to be very solid. And it turns out that the MakerBot comes out with plastic arms. That's how it comes from the factory. And within a month or two, the heat of the heated build plate has warped those arms and has changed it, and it doesn't lay flat, and it's not very good. So you'll see mine back here has aluminum build arms. And there's a guy on the internet, just like Emmett here has been putting his designs on the internet. There's a guy on the internet named BottleWorks, and he sells these aluminum arms. I think he CNC mills them in his garage or something and then just sends them off to you for $100. And it's the most awesome $100 upgrade you could possibly make to one of these printers. And the 2X and these other printers that are out there, as soon as you install those aluminum arms, the 2X and these other printers can't even hold a candle to your printer because the thing never needs to be leveled. I mean, rarely needs to be leveled. I wouldn't say never, but I went through a period where I printed on it every day for a month, and I think I leveled it once. So that's a pretty good thing. And then the other big mod that everybody's been touting is a glass build plate. Again, come up with a way to make your plastic stick to the surface better. Now let's get to the meat part, which is 3D printing of robot parts. This is the #1 problem robot nerds like me have. I want to take and couple a motor to something to make it move. And most people, they get out the lathe and they cut a bunch of metal on the lathe, and it takes them a whole day to make some little fitting that takes some $9 motor they bought at the surplus house and couples it to a $2 wheel they found at Orchard Supply. And it took them all day just to couple those two things together. And it's like, I put this great wheel on this motor. I spent the whole day doing it. And then how are you going to get to the point of actually building a robot? I mean, at that rate. So in this case, I built a coupling, I printed it out, I had it in like an hour. You know, I could do that all day long, and in fact I do. So here's a 3D printed robot. So this is a little robot you snap your smartphone onto, and a little cute robotic personality pops up on it, and it drives around and says hello, and it chases little 3D printed robotic objects. And you know what's a bummer is that I had the robot in my box, and then somehow it didn't make it with me today, and I'm bummed because I would have showed him off. But again, the whole thing's 3D printed. All the parts are 3D printed. And it's a cool little robot, and I want another one in a different color. I just print out a new one. And it's pretty fun. So in summary, there's lots of expensive ways to print. There's lots of inexpensive alternatives. I've got something printing back here which I'll pull hot off the press when it's done and then hand it around, and you can feel it's like still warm, like it's just baked in an oven. And then the last item too, and this is the thing that the big mega reason why you don't want to buy the $250,000 machine is because the consumables are king. I can buy a 1 kilogram spool of ABS plastic for that printer for around $35. A kilogram of consumable for the Objet Eden is like, I don't know, hundreds of dollars. So, you know, I can print parts all day long and they cost me pennies to make on that, versus if I used that super expensive one, it would be very expensive. And that's the reason why Shapeways, some of these bureaus, a part about the size of one of those boxes will cost you $10 or $12 or $15, and you know, just to do that one part. And then here's some links. Again, I'm in this Homebrew Robotics Club, a little plug for them. It's just a group just like this, except we get out together once a month and geek out about robots. People bring a lot of robots. We meet at Google in Mountain View. And you can go to the website and you can find out where the latest one is. It's the last Wednesday night of every month. Again, I can plug myself. You got some kind of cool Arduino thing and somebody gave you a big pile of money to turn it into a real product, call me. That's my website. And then MakerBot, obviously, this is the one. And then, admittedly, I didn't mention some of the other printers, like the Type A machine guys are here. They're going to talk about their cool printer. I left it out on purpose so that I wouldn't, like, you know, put any words in their mouth. And then that's pretty much it. Thanks.